With circles, we can calculate area and perimeter. It's just a little bit different since circles just operate slightly differently. So first, let's get some properties of a circle. So diameter's distance across the circle through the center. So what that would look like is you could choose just a spot on the outside of the circles to start. So let's say I started here. I want to draw a line across the circle, but this would not work as diameter. Diameter specifically has to go through the center of it. So from there, that would represent diameter, which we usually use lowercase d for short for diameter. Now the radius is going to be the distance from the center of the circle to the outside of the circle. So what we can do is we could actually start at the center this time, and then it just needs to end up along the outside somewhere, absolutely anywhere that measures the same all the way around. So let's say I go there. That would be our radius. So we use little r for radius. Now, a property between diameter and radius is that the radius is just half of the diameter. So if you ever need to find radius, given that you know what the diameter is, you can just divide that diameter by 2. Vice versa, you can find diameter by taking 2 times a radius, and that's how you can kind of convert between the two. Now, area, we're going to use the same terminology there, but perimeter is going to be with just our polygons and general shapes. With a circle, taking the perimeter is called the circumference. So it is the distance around the circle. So with that, just like we talked about in the previous video, is that if I imagine taking a piece of string and laying it down on along the outside and just measure around, and then you can lay that string flat and take a ruler to it, and that would be your circumference. All right, so we're going to have 2 formulas, a formula for circumference, a formula for area, but what I'd like us to talk about is just what is pi. I assume most of you, if not all of you, have probably seen or used or heard about pi at some point or another in your math work. So pi, or the symbol pi, is how you'd see it, and pi ends up being about 3.14159, on and on and on and on. It's a really special number, and it comes up so much as we use circles. But what not a lot of people have looked into is what it actually represents. So I'm going to tell you what it represents, and then we will just use calculations for it. So with pi, it comes from the circumference and the diameter. So you can imagine is if we have a circle, and this works for absolutely any circle that you find out there, is you'd want to look at the diameter and measure the diameter. And then what you would want to do is also find the circumference. So you could use that piece of string or yarn, lay it along the outside, and find your circumference. And you can absolutely do that. I do this activity with my face-to-face classes. Really all you need is a circle of some sort, any size would do, and a ruler and some string or yarn. So the ruler you'd use to measure the diameter of the circle that you found, and then the string you'd use to lay down as best you can along the outside, and then you would use that string with the ruler to measure how long was that piece of string to get that circumference. And if you take the ratio of your circumference divided by diameter, and when I do this with students in class, it's always a little bit off, but the closer you get to precise measurements there, it should come out to be exactly 3.1459, on and on and on and on and on. That's exactly what pi is. It's this ratio of circumference to diameter, and for any circle, it comes out to the same number that they decide to call pi. And then instead of having to write out this number each time, they gave it the symbol so that it's easier to refer to. And if you have a calculator at home, you probably have a pi button on it. I'll show you with GeoGebra, or even show you right now with GeoGebra. There's a pi button right here. So you can usually just use those buttons instead of typing in. I know some classes just have you like type in 3.14 and that's good enough. And that is a good rounded version of pi. However, for our calculations, we want to be exact as possible. And that's where it's just better to use pi so that it's using many more decimal places and getting a lot more accuracy. Pi has its own symbol, and why we need a symbol is because this decimal that follows, the decimal never repeats. So for example, like if you type 1/3 into your calculator to get a decimal, you'd see 0.333 repeating on and on and on. And that's where in previous math classes, maybe you've seen this form where it just shows what's repeating. But what happens with pi is that the decimal never repeats. There's no sequence to it. There's no theme to it. It's just always different sequence of numbers coming through. And this is called an irrational number. That's where you can look up videos of people who have memorized many digits of pi, and it's very difficult to do because there is no real theme to it because it's an irrational number. So with that, we'll be using this symbol for pi as a shortened form for this number with all these decimal places that never repeat. That just represents a ratio of circumference to diameter for any circle that you find out there in the world. All right, so with that, now that we know what pi is, let's use it in our formulas. So circumference and area, what you'll really need is radius. You can get by with circumference with the diameter, but with the area formula, you absolutely need radius. So if they give you the diameter, you'll just have to take that extra step of calculating radius, but they're easy to change between. So have your radius. So for circumference, you can use this 2 times pi times r, or if you want to, you can use d instead of that 2 and r. 2 times r is just the same thing as diameter, so you can just interchange between those. Just like with perimeter, whatever units you're starting with, whatever really units you're using for your radius, that'll be the same units that you use for your answer for circumference, because again, it's just a distance measured on a ruler. The area representing a region, so you'll have pi times r squared, and with this, when you get your units out, those units will be squared when you use this formula for area. All right, so let's try out these formulas. So with this first one, say they're giving us the diameter. So that would be our diameter, but especially if they're asking us to find area, you're going to want to have your radius. So I'm just going to take that 7.85 divided by 2. So we have this radius of 3.925 feet. So with that, going to our circumference formula, you could use either one here since we have diameter and radius. Let's use the diameter formula just because you'll get the same answer out with them. But pi times 7.85 would give us our circumference. So this is where you'll need a calculator with the pi function or this GeoGebra calculator online. So you'll just do pi times 7.85 and enter, and that's our answer, 24.6615. Let's go ahead and round to 2 decimal places here, so 24.66. And then for units, we will just take the units of our diameter, feet. And then for area, we're going to go pi r squared, so pi times our radius of 3.925 squared, and we'll take that to the calculator. So let's go to GeoGebra. I'll show you one more time with this. Pi times 3.925. Oh, sorry about that. Maybe I'll stick to this. 925 and squared. And the squared button you can find over here. It has this blank with an exponent. So you can type in your number first and then hit that and it'll square it. And, oh, what did I do wrong? Pi times 3.925 squared. That is much too big. So I'm going to keep this rolling just because, oh, there we go. That turned into multiplication there. So that was a typo. 3.925. That's a much more likely number. So good to have some intuition there. I'm going to leave that in the video because we all make mistakes and it's good to see those. So, all right, so we're taking this and this is a good chance to see. So if I'm rounding to 2 decimal places here, I'd stop at that 9 right there. But that 8 would round the 9 up and it's like it's rounding it to a 10. So I'd actually end up with a 0 there and that bumps up our next digit. So in terms of rounding this to 2 decimal places, I would end up with 48.4. So that would round up to a 10, which bumps that up by 1. So 48.4, and then our units are feet, and because this is area, we square it. So that's one example there. Then here's an example with a half circle, which will change some pieces a bit. Now for circumference with this, and circumference here is not exactly right because circumference is reserved for circles. So we do have part of a circumference in that we have the circumference of a half circle. But in terms of wanting it does come down to perimeter here. Because what we're going to do is if we want this distance along the outside, we also have this 15 here. So what I'm going to combine for finding the perimeter of this shape is I'm going to take that 15 plus and then whatever this kind of circumference is of the half circle. So I have this diameter of 15, but I need to think about radius. So I'm just going to put radius right here, which would be 15 divided by 2. So I'd have a radius of 7.5. So now how I would usually calculate circumference, and we could have used the diameter. I'm going to use the radius formula just so that we see both of them. But you'd have 2 times pi times the radius of 7.5. But then what we want to do here is cut that in 2. Because it's not circumference of the whole circle, it's a half circle. So if we plug that in, what we should get from our calculator is 23.56 and then centimeters. So if I'm looking for perimeter though with this shape overall, I would have that circumference of the half circle, so 23.56, but I need to add on that 15 along the outside there. So that would be a 38.56 centimeters. So that would be the kind of circumference and perimeter part. For area, we just need half of the area of the circle. So for area of the circle, pi r squared, so pi times our radius of 7.5 squared, and then we just need half of that because we only have half the circle. And that should be an 88.36 centimeters squared. So that's how we do circumference and area with circles.